Hello, can you hear me? Welcome to this panel session. Great to be here after 5 years, last being here in Levi, discussing about 6G. And great to have a panel with me today, Tom, Per, and Jari, to discuss the two key things. In 6G, we are hearing again and again about resiliency and transformations, whether it's in technology, whether it's in policy, or whether it's in business. I very shortly introduce the theme for today. We will have this thinking in 6G systems themes in this panel. 6G system and how we work with antecedents of the successful system. What are the systemic traps we may face? And what are the leverage points, how we can impact the system? This is one of my favorite books. I think it was from '74, about Zen and the art of motorcycle maintenance. And when I first read it, I considered it as a book of quality. But when I read it again a couple of years back, it was really about systems. And I would kind of ask you and challenge you to think during these 2-3 days that what is the factory we are rebuilding in mobile communication or telecoms? Or what is the revolution we are thinking in mobile communication or telecoms or 6G? And maybe something we don't want to repeat. And that's really the essential of systems thinking. And even more, that what is the flat earth in our systems thinking? What is the turf we are all protecting? And where is the edge we are kind of looking for a new world? Resilience, self-organization, and hierarchy has been found by many scholars as a key antecedents for successful system to work, high-functioning, dynamic, sustainable systems. I think the recovery part is pretty clear and we agree, but many times in my thinking we make mistakes when we think about the self-organization or hierarchy. Self-organizing, it's really not to simplify things, and it's not to make it a very productive or stable. It's the opposite. It's the kind of contradiction that it's how it structures itself, how to structure it's a more complex and create new structure to learn and diversify and evolve, like ecosystems in the nature we are part of. And the last one, the hierarchy, many times in my thinking, I have a bias thinking that, hey, mobile communication, it's about centrally controlled system. It's about top-down. We think about the control structures, not so much about feedbacks that are the essential part of the system. And really, how in systems thinking, hierarchy is something that it evolves from the lowest level up. And it's really about how it's and that's now in many 6G visions, we talk about systems of subsystems, or we talk about zones for sustainability, zones for reliability or resilience or security. 2 minutes left. And about system and in 6G, let me start with the platform thinking. And we have talked and heard already about the innovation. And that's the engineering way of thinking about platforms, that it's really a kind of innovation platform where we have a kind of supply side dominating. There was a good question, is 6G a bit pipe, another type of vertically integrated supply chain and this kind of supply side business. But I propose that we start thinking 6G now as a hybrid of innovation platform and transaction platform. And that comes from the more on the economics or business side, that how we can match and bridge the supply and demand. And here we are talking about context, we are talking about marketplaces, e-commerce, cloud computing, AI, kind of the higher layers on top of connectivity. What comes from IT industry, cloud industry, now AI mentioned many times. And to build this type of ecosystem around these platforms, this creates and forms complementarities. We have heard many times you can't build this alone. You need to collaborate and collaborate widely. And in the past, we have mainly collaborated on this technology side or technological, innovational, or input complementarities on the supply side. And now I really challenge us to start thinking on this demand or consumptions or exposure side of the story, how we bring complementarities in from consumers, government policy, public-private partnership mentioned many times, and having these APIs, not only on the network side, but as well as the service application and exposure side. That was in keynotes already kind of proposed as a way to monetize or capture value from 6G. And to conclude, the other side of the coin is then externalities, and that's about spillovers. That when more we open the system, more we open the architecture with open APIs, service-based architectures, there will be spillovers, positive spillovers, but as well there could be negative spillovers. And the question is that how we master this, how we scope. The good news is that having platforms standardized, agreed, harmonized in scale, that helps. Having as well ecosystem, that helps on the business side. But there are a lot of as well challenges or traps with externalities. I heard already many in keynotes. How about if we have diverging standards? How about if we have scattered product offering? How about if there's kind of we are not able to agree on the value created and value captured or shared? How we balance this? Who profit from the innovation? And it's easy to say that, hey, we have social value, but how we monetize this, that who is inventing and innovating the technology, and then if there's a spillover, and then it's utilized benefit by others and society. It's good for the society, but there's really a challenge on business model here. And that's the theme today. We will discuss 6G resiliency and this transformation. And each of the panelists will shortly present their thinking in 6G systems on this theme, and then a couple of questions, and then I open the floor to audience to ask more questions and comments. Next, I'm happy to introduce Tom, please, from Department of Defense, and we will dive deeper in the resiliency in critical operational networks and Department of Defense or for warfighter perspective. Tom, please.
Thank you, Seppo. And good morning, everybody. Thank you for having me. Thank you. So when I think about 6G, I want us to think about three specific words: secure, open, and resilience. These all mean something fairly general, and they're harder to measure than some of the other measures of performance that we've been used to trying to strive for in previous generation networks. The reason why is because we have to start thinking about the future networks, well, really all networks, in fact, all technology, as a people-centric vision, as a people-centric pursuit. We tend to get wrapped up in these ideas that the technology we're building needs to be advanced for the sake of advancing technology. Whereas I think of it as we need to advance technology for the sake of the people that it's there to support. And when you look at what we've been pushing for in all the generations of technologies up to now, that really has been in mind to create a business case to serve the consumer. So if we look back at the history of telecommunications networks, wireless telecommunications networks, 1G proved that there was a technology that could be scaled worldwide to provide a mobile service to customers. 2G made a really good business case out of voice communications to an end user. 3G proved that we could produce wideband data to the end user at the scale of the globe. 4G, again, made that really good business model for supporting broadband data to the individual users. Challenge with 5G is it's been a revolution. It hasn't been about the consumer. It's been about enabling capabilities, enabling applications at the edge that create new verticals, new market spaces, new application areas. Each one of those is designed to support an end user, the people that it's there to create the next generation of benefits for, whether it's health, automotive, and transportation, agriculture. All these things are very people-centric, but there's we've removed ourselves one step by trying to support those vertical areas. So I've been very positive about the development towards 6G, following those trends of the previous generations. That as we try to introduce these new technologies, pushing the technology to the edge, these even generations come around and help us really understand what those markets, what the consumer, what those edge applications really require out of those networks, and we build towards those. So now what we're doing is critical in order to transform this idea of supporting these different edge applications for all these different possible use cases into a working, sustainable business practice. So keeping that in mind, as we're pushing towards these secure, open, and resilient communications platforms, that's because each one of these new edge applications is going to require those to make both the technology at the edge work, but also make sure that they are supporting the edge application and the users that are using them. We want it to be secure. There's so much more data being produced on these networks all the time. We need to make sure that that data is secure, protected, that the people's privacy is respected in those. We want them open so that we can actually understand how these networks are managing their systems, managing their data, managing the end applications. We want them to be able to be executed effectively. We need simplicity out there, and we can't have simplicity if you have these closed monolithic systems. You need to integrate that with the end application. And we need them to be resilient. This is critical in times of conflict, natural disasters, increasing cyber attacks against our critical infrastructure. So all these need to come together in order to build a resilient, reliable 6G network so that we can create the business case. And I'm sitting here from the United States Department of Defense because we also want to create that national economic security case for all of us to benefit from and to secure our data, our people, our population, and our rights. So I'll pause there and get to the next speaker, and I'm sure we'll have plenty of time to dive in some of these farther. Thank you.
While waiting for Per from Net Insights to upload the presentation, I have one question for you, Tom. That thinking about openness and open APIs, particularly in US, I think the Open Run is now piping. And what do you think? How does Open Run create resilience, or will it? What's the connection between Open Run type of opening up interfaces in the run and resilience?
Yeah, I think they're very closely tied together. The way that I look at security is threefold. You have your traditional, at least in the telecommunications and computational networking space, you've got your traditional cybersecurity. So we need to be able to, and cybersecurity is not a solvable problem. In fact, it's provably unsolvable. So you have to be able to address and attack cybersecurity threats as they come up. You have to be very quick about it, and you have to constantly work at it. the more open the architecture of the system is, the more we're able to dive into each component and understand it from the cybersecurity perspective. I know there's a version of this theory out there that says, well, there's more interconnections, there's more attack surfaces on these Open RAN networks. But I look at those as actual opportunities to protect them, to instrument within those Open RAN systems, to be able to monitor, measure, protect, and deploy fixes when cybersecurity vulnerabilities happen. You also have supply chain security, and this is something that we're already starting to see proven out in the Open RAN market. By disaggregating the systems, you're creating opportunities for people to innovate and to produce solutions at different parts of that RAN stack instead of a single monolithic box that you have to buy from a single vendor. That's opening up possibilities for diversity within the markets, for diversity within the value chain, and that's providing another level of resilience that we can actually we can now have different supply lines coming to us to support for rebuilding, repopulating global networks. We also have the need to protect our own economic futures with these new applications that come by. And that's really a third level of security that we need to be looking at. There is the need to continue to innovate and to continue to provide those new technologies supporting these new use cases. And now if you have that Open RAN architecture, again, you don't need to build, if you want to innovate in the RAN market right now, you have to build your whole RAN system for yourselves in order to be able to prove it out, test it out, and possibly sell it. By allowing us to have access to different parts of that RAN stack, you're able to innovate faster on places where you have a good idea. How do you get your good idea proven out, integrated into the system, and then rolled out to the market? So this is a way to actually speed up innovation and create that next level of rapid management of the end applications that I talked about in my opening remarks.
Thanks, Tom. Next, we will talk about synchronization. And in system theory, it's really every single system to be successful need feedback. And synchronization is essential part of feedback. So Pat, please.
Thank you, Seppo, and very great to be here today. Yes, so definitely I think both Seppo and Tom said when we're moving from, I think we'd already done that when we're moving from 4G to 5G and now to 6G. If already 5G is really critical infrastructure for a lot of the both enterprise services and our government services. But I want to highlight one area that has become very critical when moving from the 4G that was FDD to 5G and 6G that will be TDD, and it's the time synchronization. So why is time sync important? Well, first, of course, with TDD, it's a fundamental requirement to have accurate time and phase in the network and not just the frequency synchronization, but also many of the new advanced network functions, whether it's carrier aggregation, network slicing, and even massive MIMO, time synchronization and TDD is required for highest performance. But finally, also a lot of the new user applications around accurate timestamping and also precise positioning requires accurate synchronization. And of course, today we relied very much on GPS or any type of global navigation positioning systems. And problem with those, of course, it's very weak signals and it's very easy to jam and spoof these signals. So that's all of a sudden, and we've seen this, we kind of taken GPS and GNSS for granted. It's very easy to put up a GPS antenna and it will synchronize our networks and our services. But I think the geopolitical situation the last years have shown that we cannot rely on GPS and GNSS anymore for the synchronization. It has to be handled through the network to become reliable. And it's not just the mobile networks actually that rely on this today. I think there were reports now both from the US and from the UK looking at the over-reliance on GPS and GNSS systems. And I think both those reports show that just losing GPS and GNSS for one day, the cost for those countries is over $1 billion per day. And that does not include that the 5G TDD networks will go down. It's just the positioning services that will go down for the applications and the end users. So it's a lot of money, and it's quite interesting that we build the 5G, 6G networks. We think about all the resilience, how we build redundant networks, but we rely on a single point of failure for the synchronization. It is true that we can do this today over the network, but still the vast majority of the operators rely on the GPS and GNSS for their synchronization. Regulators, they've also started to realize this, and several countries are considering to mandate already the 5G operators to not rely on satellite-based synchronization. Actually, Sweden, where I'm from, Sweden was the first country. When they put out the 5G licenses, it was a mandate and that all 5G operators have to have a backup for GPS GNSS by 1st of January 2025. And I'm quite certain in the discussions we're having now with other countries that a lot of other countries will follow forth on this. And I'm quite sure for the 6G, when we are even talking about even more critical services and applications, this will be even more on the agenda. And I also spoke just the other weeks with the ECGRC. They are putting together now working groups looking at this also from a European level. So I'm quite convinced a lot of countries will follow the Swedish model when it comes to 5G and 6G. So very much now we're talking about the synchronization as a threat, and what my vision is that for advanced 5G and 6G, we should not talk about time synchronization as a threat, but it's a big business opportunity, and I'm sure the mobile networks has a big business opportunity to provide this precise localization through the mobile networks. But of course, that requires that you do not rely on the GPS for actually building those mobile networks. So thanks. That's just yes for me on the synchronization.
Thanks, Per. And next we have Jari Partanen from Bittium talk about end-to-end connectivity. And Per, I have one question for you, that thinking in 6G systems, a low level up, so how do you see the role of network-based synchronization? That's really how low in the systems hierarchy or architecture we can start building the sync up instead of going to the satellites and really centralized way. So what's your thinking here?
I think there are standards today, of course, for doing the network-based synchronization. It's the IEEE 1588 and PTP standards. So I think it's more for the operators to start deploying this and using it. However, there are flaws in the current standards, especially for the security aspects in PTP. So these need to be overcome. Also, one problem is it's very hardware dependent. Every line card in every router or optical switch is involved in distributing that synchronization out to the base stations. So it becomes quite a complex solution to do this on nationwide networks. And also many operators are relying on leased capacity still. Of course, if you are more traditional PTP, you have a lot of fibers, then it's fine. But when you're leasing capacity, you do not control your synchronization yourself anymore. So there are now standards and there's standardization now ongoing in ITU to look on also looking at overlay and virtualized synchronization solutions. And I think that's going to be very important also to virtualize and containerize this, not just rely on like hardware dependent synchronization models in the future. Then as always, of course, the APIs. And I think also when you have these time nodes and time functions, try those metrics up to that, to the the management system is a huge opportunity to create that data lake for future applications. So that's another area of monetization, I'm sure, for the future.
Yeah, thanks, Per. So Jari, the floor is yours.
Thank you. First of all, thanks for the honor of to be in the panel for talking. I think my few cents for this event are as follows. So everywhere when we have had communications rolling on and keeping in the momentum and developing, and when looking for the 6G, I think at the moment when we are talking about user or somebody else perspective, it should be end-to-end secured somehow. It should be seamless, secure, and also resilient communications, what we are creating, an end-to-end perspective. And my idea for this is that actually there's a potential for kind of enhancing the digital resilience and looking from the domain and various domain scenarios. So I think there's a lot of opportunities. When just hearing for all the intros of what we have had here today, so I think this is really complementing this in an aspect. If we are looking at the moment, this is not the latest one of the IoT market forecast, and if we are looking about 5G IoT, share of this, it has been quite low, but significantly growing, and looking that it is really going to be kind of growing towards when 6G era is coming. But still, it has been some of the thoughts why it hasn't been flying in the original momentum is that where to use and what is the domain perspective or where's the needs for this, and then comes that after the needs comes that there is the volume for the implementation for this. Second highlight I would like to kind of show from a medical world. So for example, there's a lot of different type of sensoring for the people's health. So we have in-hospital type of health situation where somebody's in hospital, you are being under treatment. But then is another aspect which is outside the hospital. And there's a lot of opportunities for this type of end-to-end remote diagnostics, and remote diagnostics for that sense that when people are on the move, you can be able to kind of sensor and monitor some of those. If there is some issues with problems for the health, you can monitor for that. And that is going to be kind of really growing. Some of these are not, medical grade applications, some of these are not. But there's a really potential for this and end-to-end. And why it's used and why you are collecting the data is that actually you are somehow then looking from the doctor perspective that what is the outcome of this data, what is the analysis you can make out of this data. So basically all the connectivity is connected to the data pipeline of this and this analysis of this, where AI and machine learning is going to be in the future more and more important also to discover. Second kind of domain I would like to highlight from the military communications world, where there is a tactical network, for example, with various type of areas and connectivity points for this. This has been also a research type of issue that how to make current 5G connectivity architectures, the interfacing with the secure interfacing for these type of systems, and how to make the robust communications to be happen. One of the examples is EDF 5G Combat, which is a big research program looking for this aspect as well. And I'm looking forward towards the future when there is going to be like there's NATO Dyna 6G test centers now established in Oulu and these kind of things. So there will be evolution for this and opportunities for this also in the future. All of these have some of these kind of issues that how we should develop the digital resilience for this. We need to create somehow the trust for the secure and seamless communications and architecture from end to end with the different type of applications, and it has to be truly end to end. Somehow this kind of encryption of the data, we have been hearing a lot about the need for this, but how we are making evolution for this, and then also looking for the post-quantum crypto technologies, like what has been kind of emphasized, like from US, that it will be used in a very much for the kind of governmental purposes in the future on. But their combinations, we need to develop those further. Then we need to kind of create that if we are ever connecting something into these networks, so we need to kind of consider that how to make these networks that there's the kind of zero trust architectures inside these as a kind of, in a sense, as a kind of one essential part of this. And then I would highlight the meaning and importance of the digital twin simulations. I myself was experiencing some 5 years ago, first time making this in a large scale, and saw the benefits and the potentials for those. And I think now we are gaining a momentum for the 6G, that how to make in a truly in a large scale. And this is meaning that whatever there comes, there might be various type of things that we are practicing also, and making these kind of scenarios that whatever happens, what we are going to do next. And then this is also a point of that we need to kind of make comprehensive standardization, not only just for 6G standardization, but also for the domain perspectives, that how we are have an interoperability with the standardization, that we can really truly kind of make the end-to-end to happen in a large scale. So this was basically my points for this discussion.
Thanks, Jari. One quick question for you, and that's that many times in systems thinking, the driver is really the productivity or stability. And the question is that how we actually in this end-to-end thinking, how we sacrificed resiliency for productivity and stability and simplicity. Because you think what's the theme was, that's kind of contradiction to how systems should be things designed to be resilient. So the question is about productivity and stability versus the resiliency in the system.
I see myself that basically it's actually the same phenomena from this perspective, what we are talking about. From this perspective, even we are making like digital twin simulations beforehand. Yeah. It is actually helping to create actually end-to-end solution at the same time. So we are at the same time developing the cybersecurity of the system, but also we are developing that how the solution and is working at the end. We need to kind of do a lot of for the hardware digitalization to be make like it, that it can be simulated as in a digital twin also. But I think this is the evolution what we are at the moment interfacing. And I see myself, and I have seen that it's not sacrificing truly the productivity at that respect.
Good. Sorry. Hey, I have one question for all the panelists, and then I give it's open floor to the audience to ask more questions and dive deeper. And thinking about 6G future visions and now the concepts or architecture concepts or others, that how do you see that, where do we have leverage points or places to intervene in the system to make it more resilient for, and not only for military applications, but operationally critical applications or to serve the society? And I think that's the key questions in systems thinking, that, hey, where's the knob you have to, where to tweak the system to avoid the traps and really have the most kind of lever or impact there. And Tom, would you like to start about where's your favorite leverage point in mobile communication system?
Well, so even though my official degree is electrical engineering, I spent most of my professional life as a programmer developing software-defined radios. And so I look at the software as the areas where there's degrees of freedom now, more so than we've ever had before. And I think really exciting is the integration of software-defined networking concepts into the core network. And that's where I think a huge part of this can start, is by understanding that as we're pushing the software definedness, to coin a term, of these systems, you're now talking about more commodity hardware. And now the specialization is in the software and how that software is able to leverage that hardware. That changes a few things. First, it allows us to think of our upgrade cycles now in terms of upgrading on a similar IT path for this ICT world that we're in. But it also allows us to start thinking about how we can leverage the cybersecurity concepts that has been developed in the cloud computing world and in software enterprise technologies. I come from an open source software background. We've developed a lot of capabilities to create the infrastructure to build, test, manage, and deploy systems very effectively in light of resiliency and security. And to finish off here, as we go back to your question about Open RAN, as we open those systems up, that's the same. Now we get to take those concepts from the core network out into the radio access network and add the same kind of features there.
What's your view? What's your favorite leverage point? How to make the difference?
Yeah, no, I think really, well, first, of course, we need to look at an end-to-end point of view, and I think the open APIs to be able to also both leverage all the data that we have in the network, both from the future sensors, but as said, also all the metrics that comes from the data. And we can use that for many different things, both for the monetization parts, but also as leading indicators to see where things start to happen in the network. And of course, with the synchronization, when we look and we see, when we have all those metrics on a nanosecond level, instead of milliseconds or hundreds of milliseconds that we have today, we see totally new patterns, and we can be much faster to response. And I think those resilient networks and self-healing networks, and to be able to find those problems, we should look much more faster. And of course, that connects into the AI part, of course, in that as well, for self-healing and developing networks.
And Jari, in your end-to-end architecture, where's your leverage point?
I think this part of the thinking of the seamless first, if you think about that, how much we are having when it's 6G area, how much we are having actually background communication and architectures and things, what we can use to how to make truly the seamless, that if something is not happening, we can use another communications in the background. So it creates a seamless type of this. Then comes that how we will make secure that in all these aspects, it is at the same time secure. So we need to compromise somehow that how it is done in a kind of very smooth manner. And there's a lot of also applications potentially which are not creating a need of really massive data for example, this type of health applications. It's not a big data punch for this required to capture from the sensors. So sometimes it's enough to use those other technologies which are available. But then comes that these crucial points, that how to really make it resilient, that we can really recover. So I think we need to kind of somehow make this visual simulation of all of the things, and that it is a continuous kind of path of what we are doing, and we are doing all the times when it comes new type of. We can ever kind of do simulations for all of those potential kind of scenarios, but we can do a lot of, and when we learn, and with help of, for example, we can see, for example, from ChatGPT, it's not meant to use, for example, to make kind of cyber security attacks at the moment. But I have seen some applications in the research for like in some Horizon Europe programs, how efficient it is collecting the data, where's the potential breaches for the issues. So this is something that we need to do in a kind of very concise and constant manner, I think, for the future.
Do you think that 6G will be a system of subsystems? And one word I have not heard from for years is that mesh networking. It used to be a hot topic 10 or 20 years ago, but do you think 6G will be a system of subsystems or zones? Will there be a mesh network? Thinking about this hierarchy from lower layers up, or is it still kind of about centralized?
I think there is more and more needs for the edges of this. So and this will create, when we come to the applications, so we are, I think the edges, using the edges for the calculation, really close to applications or the need of the data when considering the data. So it's not in a centralized that manner potentially, and this is one potential what we are having.
Good.
Yeah, and from a military perspective, we use mesh networks all the time in the field these days. And so some of the concepts, side link and those types of things that are going into the standard are opportunities for us to try to take advantage of that. I think the challenge here, and you brought it up in your opening remarks, and I hinted at it a little bit, is changing assumptions on how the systems behave today. And how the systems behave today are that the telcos like to sell a service contract to an end user. And these mesh networks don't really support that business model. As the business models are changing now to these service level, potential service level models, where now you have to rethink your business practice, they could open up opportunities for something like that to happen. But it takes a change in the business model more so than a challenge with technology in this case.
Good point. Good point. René.
It's interesting you asked that because we actually talked about this morning about meshing.
Yeah.
And I think from a resiliency point of view, definitely mesh networks is always going to have its advantages. And I think definitely we need to think when we're talking 6G, it's very often just the radio, but the network is so important for both the resiliency and performance of that network, and how you build your end-to-end network in a resilient way is key. When it comes to your question on subsystems, I think that's the way to think about everything, and then again the APIs becomes the critical aspect in how you build this.
Thanks. Okay, so we have great 6G brains in the audience, and we have time for comments or opinions or questions. So we have microphone right over there. So anyone who would like to start? Peter.
Yeah. A question mostly maybe for Tom and Jari. In the US, we talk a lot about dual use. So using technologies for networks in defense as well as in civil applications. Where do you see for 6G the opportunities, and where do you see more the challenges?
Yeah, so our perspective from the US DoD is that we really do like the idea of commercial off the shelf, the scalability of that, and again, from the supply chain resiliency concepts. We've gone to that in many different areas of technology already. We're trying to do that now with these 5G and in my role, future generation wireless technologies. The challenge there, of course, is that the information that passes across these networks is vital to our command structure, to our decision-making structure, and decision-making superiority is what we talk about from a military perspective. So anything that compromises the security aspect of that, the ability to move that data, to ensure that it gets to where it needs to go in a timely manner, and that it's the data that was sent from the original transmitter. All of those things are really vital to us. And so there has to be an understanding of the security model in these network systems that's more paramount than many of the other commercial off-the-shelf systems that we've been using to date. And so therefore, that's, this is where we all come together. We've come together both in a joint statement that the US and Finland made last year on these types of concepts of resiliency and transparency, openness in the networks, but also now the joint statement that the White House put out with 10 other countries or 9 other countries with the US, again, talking about those words, secure, open, and resilient by design. Those are key features to us and to our partner nations that signed on to that with us, of creating that base 6G technology that supports those concerns for us, while also leading towards what we believe are the future applications that these networks support.
Thanks, Tom. I'll add to that I think the security requirements that you have for your command centers are also in civil applications increasingly important for industries, for companies. They also want the data that goes across the network equally secure.
No, I appreciate you pointing that out, Peter. Yeah, exactly. As we look at things like, the connected vehicles and these different verticals that we're thinking of, healthcare, autonomous vehicles or connected vehicles, the impact on safety of life and criticality of it on the people that it's there to support, back to that theme, is pushing industry into thinking about these as more secure and more resilient architectures anyway. So absolutely, there's now more parallel than ever in civilian applications of these technologies as the military. Thank you.
Jari, would you like to add something? Anything to add from your perspective?
I have just to add for Tom's. I think it was really excellent answer for that. I think, for example, this domain of health applications. So we need to kind of keep the data always. There's the privacy issues for the data naturally, but it's also health data. So you need to keep that there is really separated those issues, and that's why we have to create the end-to-end concepts, that how we are kind of developing the concept for the resiliency. And I think there is a lot of why I wanted to kind of show in various domains that the challenges are the same. Basically, that it needs to be kind of taking consideration what is the domain requirements for this in the future. So I think this is and very much kind of complementing what Tom was saying.
I can.
Thanks. Joseph Noll, University of Oslo. I have a very specific question to the use of digital twins and the zero trust architecture. From our work, it's impossible to actually catch a zero trust architecture through digital twins. But then, following up on what Peter said, aren't the security requirements driving us into a cost factor which actually limits us from connecting the unconnected?
Yeah. So I think the digital twins, we are getting more and more learning where we can use those efficiently. So I think the first applications where I was involved with those was that actually it was done in that perspective, that there was actually a factory, and from the factory floor you were creating the whole pipeline towards the whole kind of delivery chain of that, how it's. But it was also collecting the data from the factory, and it was seamless and secure, but also at the same time there's a digital twin which we were able to simulate with various kind of attack scenarios. For that, the zero trust would have been that we shouldn't have kind of trusted of any devices for those, but we were trusting for those devices which had certain architectural components. So I think it means that for the zero trust, we have to think about what are those connectivity factors and what kind of typical scenarios when we are creating a trust for those. And maybe it can be also in the future that we have also this kind of certifications for the trust for the devices itself furthermore also. But we have to also remind that it's going to be a lot of various type of sensors, and this is something which is it's a very tricky world for that.
Yeah, there's actually an exciting new or developing area of technology that I'm particularly excited about called privacy enhancing technologies.
Yeah.
And so if you look at these, you have things like, in particular for some of these really challenging issues of transparency and security. So how do you be transparent and open and also secure? This is you want the architecture, you want the algorithms, you want all those things to be more exposed and transparent, but you want the data itself to be secure. So that's been working okay in the traditional cryptographic model, where data in motion is encrypted or data at rest is encrypted, but data during computation has to be unencrypted, and that's where some of these system concepts break down. So some of the investments that I've made in my career are in fully homomorphic encryption that actually allows you to compute on encrypted data. There's also a corollary to that called multi-party computation that actually spreads out your data to so many different systems to compute on it that it's impossible for one system to recreate the entire data set. These are really interesting technologies, mathematically fascinating. To your second point, when we started some of the work on fully homomorphic encryption, when in my previous job, to compute in the homomorphic transform was 1 million times more expensive than it was to compute on the plain text. That was a computational burden that very few people were willing to accept. And so we've been driving towards technologies that close that gap. And the closer we get to closing that gap, the more types of applications open themselves up to the utility of these types of technologies. But I will point out that your argument was made in the 2000s and even 2010s about HTTPS everywhere, using TLS for all connections on the web. It was too expensive to deploy until it wasn't. Until Google basically said, nope, we're all going to do this. And if you don't, you're really not part of the internet anymore. So what we saw was that when there was a pressure or an economic gain to be had, either one of those, either a net negative to your bottom line or a gain to it, the commercial world closes these types of performance gaps fairly quickly. And now encryption everywhere on the internet is, yes, it's an additional burden, but it's still it is out there and it exists. I think we can start taking these ideas to the edge. There is a program working from DARPA, working with the University of Southern California on how to actually provide very inexpensive encryption for IoT devices. And so there's some kind of glimmers of hope of new technologies that create that kind of encryption at the edge. So I think that's where we have to start looking. I don't think it's an impossible task. I think it's just a hard task.
We have still time for one or two questions or comments.
Hi, Craig Gibson from DupeWise AI. I have a question. 6G is supposed to make things more efficient, but it also will probably make bad things more efficient. In a data-based, data-centric network, you're pulling information into your AI data sets. From a resiliency point of view, is there any work being done on the resiliency surrounding the loss of trust in the AIs managing 6G?
I think I know I feel like I'm hogging the microphone, but the answer to the question is yes. There's absolutely a number of programs out there. Again, looking back at some of the DARPA work that we've been involved in, but also the National Science Foundation within the U.S. has a handful of programs addressing exactly that. Trusted AI. We actually, in fact, so I'm the principal director of FutureG within the Department of Defense. I have a counterpart who is a principal director of Trusted Autonomy and AI. Who is overseeing the work within the U.S. and the Department of Defense in the United States, exactly to that question. So there's quite a number of programs that are existing today to try to push technologies that help us understand what's happening in the AI, to model it, to get clarity about what's happening. Because I think trust is one of the big challenges that we have, and from that command decision that I mentioned for the military commanders out there. Trusting a computer to make decisions for them. They know they need that speed, but they need to be able to trust that. And so that's going to take some time, some education, technology, and some hands-on experiences to understand what we can and can't understand about these systems.
Please go ahead.
Yeah, so of course, there's no debate about resilience being a very important characteristic of any network, especially in the present environment on the edge because of the radio part. The terrestrial part is reasonably well understood because internet by nature is more secure and more resilient because of the fiber being deployed as much as possible. I think the greatest risk is because of the attacks and jamming on the radio part, and how to make it resilient from that standpoint is the biggest challenge. That's what I think. I'm not the expert. However, when we talk about open systems, when we talk about transparent system, it gives you resilience, but at the same time, it opens your system up for attacks and jamming much more. Because people, there may be methods to get into different parts of your overall system because of the openness. If you make it too open, then you don't know who is controlling what, and especially in the open source world. But that's a different topic. The thing that I wanted to specifically ask the panelists: are there metrics or requirements on uh, on how do you quantify resilience? How is the edge part more resilient, the core part, and the backbone part, and how is the overall resilience measured quantitatively, and how do you compare that one technique is better than the other? So is there a performance specification for measuring resilience at the end of the day? Without that, we would not be able to understand which system is better than the other one.
I think we are out of time, but I actually think that is a key question. And in terms of, I'll kind of take it real fast from a military perspective on our wireless or our radio communications in the field. We look at things like low probability of X. That could be of intercept, of detection, of geolocation or exploitation. We also look at things like jamming. So we have anti-jam technologies. And each one of those, we have some form of measurement for how we understand what they mean for our ability to deploy them and to use them. So how much jamming to signal ratio can you sustain your communications channels through? Those types of things. Do they translate one for one to kind of consumer commercial uses? That's, I think, remains to be seen. I think there's some lessons to be learned and shared between those two worlds. But I don't think that fully addresses everything about resilience. And I think that that's a really key aspect that the community here is well suited to help us understand what aspects of resilience do you care about, and how do we make sure we plug those in for some kind of metrics that we can start to tackle.
I would actually turn back to the audience that there are many people from a HexaX and EU-funded research projects working on key KPIs and key value indicators. So have it in HexaX2 or others, have you defined how the resilience is measured on KPIs? Mikko, for instance, that if you pass the microphone to Mikko, that maybe Mikko remembers how the resilience is measured in Hexa.
Well, at least one of the main things that has been up there already from 5G is that what is then the probability that you reach the message through within a certain time interval. So that's at least a very kind of clear and simple measure that has been there already for some time. And that's also getting quite some attention in 6G. So yeah, I would start from that, and then there is some more detail into depth.
Yeah, but that's good. Less is more. So very simple KPI for that. Hey, thanks all for participating, and thanks for the great panelists. Let's give them a big hand.